Okay, let's join. Let's continue our topic. Is it visible?
Sir.
Yeah, okay. Thank you. Okay, I think yesterday we have stopped somewhere. Yeah. Yesterday, I think we are discussing about this problem. Right? And to see the indeterminacy of this frame. Now, first of all, let us try to discretize this into different parts. Okay, suppose let's say I will discretize till here, discretize till this point, I will discretize till here, I will discretize till here, I will separate or I will discretize. So let us divide this entire frame into number of parts, and then let us see how we can understand. So this is what our first part, let us say. And I think this is what our second part. And this is what is our third part, fourth one, fifth one, and then finally our final thing. Okay, what we have done is that we have just divided this entire frame into different parts. Now let's see. Now, coming to this part one, how many reactions will develop at this support?
Each 3.
Here 3, right? Now, what about at this end? As we are separating it from the frame, and here also how many reactions will develop? How many reactions will develop at this end?
Which end, sir? The first number end. Same only, sir.
3, isn't it?
Yes,
now,
sir.
Now find out how many extra equations we need in this part. How many unknowns we are having? 6.
6.
If this entire frame is stable, then obviously this will also be stable. Then for this part also, how many equilibrium equations we have? 3. So 6 minus 3. So total for this, how many unknowns we have?
3.
3.
3.
Right? Now, let us assume, let us keep these 3 aside, and let us assume that this 3 is known and this 3 is known. Already in our hand, how many additional equations we are having? 3. Let us say we have those additional equations, and then we have find out these 3 unknown and these 3 unknown plus. Now tell me, if these 3 are known, can I know these 3?
Yes, sir.
I can, right?
No, sir.
No.
Yes.
If I separate at any one point, then we already discussed, right? As suppose, let us say, if you are talking about this point A, and if we separate it, equal and opposite reactions will exist, isn't it? In the same way, if I know these 3, I know these 3. Now, similarly, at this point, how many unknown forces will be there? At this end?
3.
3. As I'm separating it, 3.
3.
Similarly, at this point, how many will be there?
3.
3. Right? Now, already these 3 are known, isn't it? This is known value.
Yes, sir.
So total, how many unknowns are there in this part?
6.
3 plus 3, 6.
Unknowns.
Then again, if it is to be unstable,
6.
it has to satisfy equilibrium equations. Then 6 minus 3. Again, what is the indeterminacy for this part again?
3.
3, isn't it? Now, come to here. Now, let us say again, I am adding this into the number of equations list. Now assume that we have those additional 3 equations, And then we have found these forces also. That means this is known, this is also known. We are imagining that. And then here how many reactions will exist?
3.
3. If this is known, may I know this or not?
Yes, sir.
Yes, sir.
Then, okay. Now how many equations will exist here?
3.
3.
Now total how many unknown forces are there here?
3.
3. How many equilibrium equations?
3.
3. That means this part is no additional equations are
0.
required. That means this might can be also found. Now, here how many will exist? 3.
3, that is known.
This is also known. So this is also known. Now, at this, how many reactions will exist? 3.
3.
Now again apply equilibrium equations here. How many unknowns are there? 3. How many equilibrium equations? 3. Now remain indeterminacy 0. That means if this 3 is known, this is also known. If this 3 is known, I know this 3 too. Right? Now come to here. If this 3 is known, I know this 3 too. Isn't it? That means at this point, how many will exist? Again, 3. Total how many unknowns will be there? This 3 is known, this is known.
3.
If this 3 is known, this is known. So how many will exist? 3. That means 3. How many equilibrium equations? 3. That means equal to 0. If this is 3 is known, then obviously at this end, these 3 can be known. Now here how many reactions will exist? 3. Now total how many unknowns are there? 3. If I apply equilibrium equations, 3 minus 3, 0. That means if I can able to find any 6 unknowns, then what I can say, I can solve all the forces in this frame. So this I will say this as the total indeterminacy of the frame. As we have already discussed, indeterminacy can be divided into internal indeterminacy plus external indeterminacy. From the support you can understand, right? Suppose if you look at the supports itself, look at the entire frame. 3 will exist here, 3 will exist here. So from this, you can directly know the external indeterminacy is total unknown 6, 6 minus 3, 3. That means out of these 6, 3 will be external indeterminacy and remaining 3 will be internal indeterminacy. That means if you want to find out what is the total indeterminacy, irrespective of whether it is external, whether it is internal, what you can start with is that divide the entire structure or entire frame into number of parts and then try to obtain number of unknowns in each part and then sum it up. That is what your nothing but your total indeterminacy. Is there any doubt in this task how we have solved it into different parts and then we have obtained the total indeterminacy? You guys want to explain this for one more equation, one more problem? Sorry guys, again the same problem. Whatever you guys are saying, I'm unable to understand properly. So you can type it. My voice is clear, isn't it? There is no issue about it, right?
Yeah, clear, sir.
Okay, thank you. Shall we discuss the same topic with another case? Yeah, Ramya, in case if the fixed end is replaced by in support. Okay, let's solve in that case. Let's see another problem, let us say. In this case, let us start with simple case, okay? Imagine there is somewhere hinge around this point. Now, first of all, I think this we can solve it. Directly, can you guys tell me what is the indeterminacy of this frame?
One.
Is it 1?
Did you
Everybody
make
agrees with that?
Sir. 0.
0, isn't it?
Zero,
Why?
zero,
Because
sir.
Total support reactions are 4.
4.
Why? Because here it is 2, here it is 2, right? 4 minus 3,
2. 3.
1. That means we also having the additional hinge here. So how many members are connected at hinge? 2.
2.
That means how many extra equations we have? 2
1.
minus 1, that means 1.
One.
So this is a determinate case, right? So let us try to obtain with the same whatever we have discussed earlier. So let us say we have separated at this point and we have separated exactly at the hinge point and then we have separated it here. Okay, now coming to here, let us say, let me write here, A, B, C, D. Now at end A, how many reactions will exist?
2.
How many?
2.
2.
2, sir.
And at this
At
point, at this end, how many? 3 will exist. So total how many? 2
Five.
plus 3, 5.
5, sir.
5 minus 3, that will be equal to 2. If these 3 are known, then I know about these 3, isn't it?
Yes, sir.
And how many reactions will exist here?
3, sir.
3 sir.
2, sir.
I am this cutting exactly at the hinge point.
No
If it is-
momento.
No, sir. 2, sir. 2, sir.
Yeah, 2. As it is a hinge, there won't be any
Moment.
internal resisting moment. So that's why moment will be equal to 0. So here how many reactions will exist? There will be some axial force and also there will be some vertical force. How many will exist?
2, sir.
2. Now tell me, if these 3 are known, these 3 can be known or not?
No, sir.
Can be, right? Now how many unknowns are there in this case then?
2 unknowns.
2 unknowns. Then how many equilibrium equations?
3.
3.
2, sir.
No, see. Equilibrium equations will not change at all. It doesn't matter whether it is a hinge or it doesn't matter. Only thing you have to see is that if you are taking equilibrium of a point or you are taking equilibrium of some section. If it is the equilibrium at point, we have already discussed. If it is at a point, what happens? Moments are not generating. So that's why we'll have only 2 equilibrium equations. That's why if all the members are meeting at one point, you will consider only 2 equilibrium equations. If we are taking a section, as moments will also generate, how many equilibrium equations you have to consider? 3. Now is it clear? 2 minus 3. Now what is the indebtedness here?
-1. Unstable.
That means we are having one extra equation, isn't it?
Yes, sir.
So already we need 2. So what I should do? I should do 2 minus 1. That means what is the net value have become? 1.
1.
Now tell me here how many will exist? Here how many will exist? 2 or 3?
2, sir.
See,
2.
don't guess any answers. Why? Because here if you guess the answer, it's not the final exam that I can give you some marks. So whatever you guys will say, just say it with the clear mind. If you guys are not getting, just let me know. We will explain.
2.
But don't
Two,
guess it. 2.
2,
Right.
sir. 2, sir.
2. Now how many will exist here?
3.
3.
3.
So these 2 already known, isn't it? If these 2 is known,
Yes, sir.
these 2 is already known. So total how many unknowns?
5.
3. 3 minus 3.
3, sir.
If these 3 are known, can I know these 3 are not?
Yes, sir.
These
No,
3
sir.
are known. How many will exist at point D?
2, sir.
2. As it is a hinge support, 2 will exist. As this 3 is known, this 3 is also known. So how many unknowns are there?
2 unknowns.
How many equilibrium equations again?
3.
3. How many additional
Minus
equations? -1.
Minus
So again, if I add -1 here, what is the indeterminacy? So is it clear as of now? About this
Yes,
methodology, how we
Yes, sir.
should go by part. But what is the thing is that here we cannot obtain separately what is the indeterminacy. Right, we are looking up the entire frame or we are looking into the parts. So that's why we may not directly know what is the external indeterminacy or indeterminacy. But with the application of this problem, I will say that if you want to find the internal indeterminacy, you have to look up how many number of loops are there, how many number of closed loops. Closed is very important. So if you want to find a shortcut, so this is what is. You have to see how many number of closed loops are there. In this case, tell me how many closed loops are existing.
1, sir.
One.
One.
So, isn't it? If there is one closed loop, so as it is a 2D frame, right? If it is a 2D frame, how many internal forces will exist? If it is a 2D frame, 3 internal forces will exist. If it is a 3D frame, how many forces will exist?
6 will.
6 will exist. So as it is a 2D, 3 internal forces will exist times how many closed loops are there? 1. That will be equal to, so now what is the indeterminacy? Internal indeterminacy is 3. So just look at the problem. You can say DSC, you can directly find out from the supports, and then internal, directly you can see how many closed loops are existing, and then just add these two values, that is what your total indeterminacy. Now is it clear with respect to some shortcut and with respect to the logic? Any doubt in these two cases? If not, then we'll continue with one more example.
Cleared, sir.
Okay, now tell me what is the answer for this case. That is, what is the external indeterminacy?
Four minus
External indeterminacy, you can look into the supports. At A we have 3, at B we will have 3. So total 3 plus 3, 6, 6 minus 3, 3 is the external. Now come to the internal indeterminacy.
3, sir.
3 why? Because how many closed loops are there? Only one closed loop is there.
Sir.
1, sir.
As it is a 2D frame, 3
Yes,
internal
sir.
forces will exist on how many closed loops?
1,
1. So total indeterminacy is 3.
3, sir.
Total indeterminacy is nothing but a 3 plus 3, that will be equal to 6. Right? What if the problem is like this? What is the indeterminacy?
3, sir.
3, sir. There is no
3.
3. Why? But total, you guys are saying
There is
total
no
indeterminacy. Tell me about internal indeterminacy.
Total determinacy, sir.
Okay.
No closed loops, right? But can you
Sir.
visualize the things? Let me visualization means, let us say that if I take this C, T, E. Now look at the joint C. How many members are connected there?
4, sir.
4, right? Now, if I separate them at the joint, isn't it? Now, at this point, how many reactions will exist? How many internal forces? 3. At this point, 3. At this point, 3. At this point, 3. Isn't it?
Yes, sir.
Can you
Yes,
tell me how
sir.
can I find all these things? This is what the support is. Imagine if you know the support reactions, if these 3 are known, can I know these 3? If I know the support reaction, 3 reaction forces, can I find these 3 are known?
Yes, sir.
That 3 unknowns is unknown only now, sir. We cannot find, right? For the AC member, we have
Known, sir.
6 unknowns. So
Now, that's what I'm saying. Let us assume that you know these 3 support reactions. Let us assume this. Let us assume that these 3 are known. Can I find these 3?
Yes, sir.
We can. Now, still, if I separated the joint, still how many I have to find? This three should be known, this three should be known, this three should be known, isn't it?
Yes, sir.
Now,
sir.
can you tell me, how can I find these three? Is there any thought? How can I find these three internal forces?
No, opposite to this we can find, sir.
At this member, how many, at this joint, how many members are connected? Four. Then how can I directly take the
Four,
opposite to them? I cannot take directly opposite, isn't it? Why? Because if you are separating at one point, if only two members are existing, then you can say that if here three is there, then here you can tell me that, okay, I'm taking opposite of them. But here,
Okay.
at joint C, how many are connected? Four different members are connected. Out of those, I am saying that these three can be known. But can you tell me, out of these three, can you find anything? Come on, guys, just think about it. You can get an answer. What about the support D? Imagine if there is a force acting at this point. If I redraw this diagram, DC, force is acting, let us say 10 kilonewton. Can't I find these three?
Yes, sir.
That means as it is a free end, there are no unknowns, isn't it? That means
Zero.
these forces I can find out it by using equilibrium equations. Similarly, look at CE. What is the type of support at E? Free end, isn't it? Similarly, as
Yes,
it is
sir.
a free end, if forces are acting like this, can't I find these three? That means as it is a free end in D, I can find these three. As because of free end at E, I can find these three. And what about here? How can I find these three? If you add all these values, how much you should get? Somebody is saying? Yes, please, whoever is saying?
Sir,
Yeah.
we see at the AC member at the junction point C, we have already find three unknowns right now, sir.
Can you please come again? Can you repeat it what you said?
Sir, along the member AC,
Yeah.
at the both end, we
Hmm.
have the known forces.
Yeah.
So the same applicable at the member, the code member at the point C also. So there is no unknown forces are here as of now.
No. Let me.
Sir, how it will be possible, sir? Not possible, sir, at the D and
Just a second. I'm having some issues today. Okay. Now you are saying that again. Let me redraw them and we will clearly look into them. Let us see. Now tell me, here three unknown forces will exist, isn't it?
Yes, sir.
Now what is your question? Here three will develop and here also three will exist. Now what is your question about AC?
Yes, AC along this member AC,
Yeah.
already we have known forces.
Yeah,
So
this
if
is known.
the known forces at the point exists to see, the automatically the code member point also the known forces available now, sir.
How come? That's what I'm telling you. See, let us say that at this point, I'm getting this as 10 kilonewton. Sorry, I'm not writing the unit. Here it is 20 kilonewton and here it is, let us say 40. Now tell me, what about the internal forces at this joint? What are the internal forces at this point and what about the internal forces at this point? Can you tell me
So
these
no
three values? You are saying that no forces are acting at this end. That's why you're saying no forces.
yes, sir. Because
Think about it generalized way. If
known
forces are,
forces.
I think, come again, sorry.
Known forces.
Known forces.
Yes. Because
What
at
are-
the cantilever portion, we find the unknown forces already. So there is no need of finding out again.
Yeah. That's what the point is. Because here, as D and E are the pre-end points, from the direction also you can find out the forces at point C and forces at point C in the member DC, forces at point C in the member CE. And then with the help of again these three, and these three, we can find out the forces in this member by saying summation of forces are 0. If still I'm not clear, we'll discuss after the class, it seems. Except here, anybody is having the doubt?
Clear,
Sir,
sir.
please explain. That is the one, sir, please, sir.
I think there is so much overlapping happening because of the network issue or whatever it is. So just for today's class, please bear about it. Okay, I think, yeah, indebtedness chapter is over. Now, let me come back to a simple problem again. As of now, you guys are very well aware of it. Now, what I would like to do is that I just want to write it down. How many unknown forces are there? How many unknown displacements are there? This is what I have to find out now. Okay. Now, let us say this is joint A, this is joint B. Now, in this case, let us see if we are talking about joint A. How many unknown forces are there? Anita, I will get back to you with that problem with an example. Let us continue with this. Suppose if you are looking at joint A, how many unknown forces are there?
One, sir.
3.
Unknown forces. Let us assume you are talking about all possible cases.
All possible.
One, sir.
2.
All possible cases. Horizontal, vertical, or load 2, right? How many unknown displacements are there?
1.
1.
What is it?
1.
So
Rotation.
at this point, along the
Yes, sir.
horizontal direction, deflection 0. Along vertical direction, deflection 0. And
Only rotate.
as resisting moment is not there, rotation is not equal to 0. As it is not equal to 0, this is what our unknown value. So this is what your unknown displacement at point A. Now, coming to joint B, how many unknown forces are there? One.
One.
That is vertical reaction. And how many unknown displacements?
2.
As resisting force will only develop in vertical direction by not allowing the vertical deflection. So vertical deflection at point B equal to 0, but displacement along x direction is allowed. Rotations are also allowed. So displacement along x is the unknown displacement, and rotation is also, right? Now, if you are looking at total entire B, AB, how many unknown forces are there? 3.
Yes.
As we know that these 3 can be solved by using equilibrium equations. That means the indeterminacy is 0. How many displacements are there?
3, sir.
Total unknown displacement 3, right? So this is what your kinematic indeterminacy. Before going to explain further, let me ask you a simple question. Let us say, if I draw the deflected shape of this beam, it might be somewhere shown like this. This displacement is also not known, right? We are, let us say, while turning the kinematic indeterminacy, what we are taking? We are taking the displacements at point A. We are taking displacements at point B. But why not in between the B? Have you ever got this doubt? Why we are taking only at the selected points, or we can say simply at the joints? Why not in between?
Support will resist it.
Any idea? Supports? We are taking only at the support, that why not at the in between the beam? They are also not known, but still we are considering only at the joint points. Why? Because have you guys taken finite element course?
No, sir.
Okay, you guys are in which year? Third year, you guys
Sir,
are in
everybody has completed engineering, sir.
okay. Finite element course you guys have not taken in your BTech course.
Finite element is an optional subject, sir. It was an elective.
Okay. So nobody offered it in your college.
Yes, sir.
Okay, now what happens is that in finite element, what we'll do is that, let us say, I have considering this as entire one element. If I'm considering this as entire one element, this is what the joints of the element. This is what we will call it as the nodal points. So what happens here is that whatever the displacements we will find out at the nodal points only. Displacements at the nodal points. If I consider it as one element, then I will say this is one nodal point, this is one nodal point. If I discrete it into two elements, this is element 1, this is element 2, this is my one nodal point, this is my second nodal point, and this is my third nodal point. So, depending upon the number of elements you are considering, at corresponding nodal point displacements can be obtained. After knowing this nodal point displacement, then what will we use that? We will assume shape function. That means, or we will consider it as a displacement function. So, if you know the displacements between the nodal points, or if you know the displacements at the nodal points, you can find out the displacement in between them by using the displacement function with the help of the displacements at the nodal points. That means, if you have obtained the displacements at the nodal points, with the help of those nodal points, you can find out the displacement in between any point of the beam. That's why wherever if you are talking about the indeterminacy, always we will speak at the joint points, or simply we can also say it as a nodal points. So whenever if someone explain you what is kinematic indeterminacy, the first point you will say it as a independent. So always we have to see how many independent. That means if I talk about this simple beam, what about my, well, initially what I am doing? I am assuming that this can be known, this can be known, and this. If I can find out these three, with the help of these three, I can find out the displacement at any point in the beam. That means with the help of these three, I can find out at any point. So that's why, what is the independent degrees of freedom? 1, 2, 3. So no need to consider at any intermediate points. So whenever you are finding the kinematic indeterminacy, always you say independent degrees of freedom. As of now, clear about kinematic indeterminacy?
Sir.
Number of unknown independent degrees of freedom that are possible in a structure, or we will say independent degrees of freedoms required to represent the displaced position of the frame. I think hope it's clear about kinematic indeterminacy. So let us just start with the examples. Let us say this or in between. Let me tell you one more thing. Imagine If I apply a horizontal force, P, can you guys tell me what is the kinematic indeterminacy here? If I apply some force, what will happen? Will it resist or rigid body motions are possible here?
Yes, sir.
Rigid body motion is possible, right? Let us assume that this beam has moved to somewhere here, just for the idealized case. Now tell me, what is the kinematic indeterminacy here? Come on, just think about it.
4, sir.
How
Four,
many?
sir.
4, sir.
4.
Let me give you an option. 1, 2, 3, 4.
Nice options.
4, sir.
4. Everybody will agree?
Oh, sir. 3, sir.
Okay, somebody is saying 3. Any other options that you guys think about it? 3 and 4. Anybody goes for 1 and 2? Number 1, right? Nobody goes for it. Now tell me, whoever says it is 3, can you please tell me what are those 3? Let us say this is joint A and this is joint B. Whoever said it is 3, can I know what are those 3?
Sir, B will be 2.
And B will be 2 and
A will be 1.
at A will be 1. Okay, fine. Whoever said it is 4, can you tell me? Can you judge your answer? Can you justify your answer, please?
Each 2.
No, sir.
Each support 2, sir.
Sorry?
Support A2 reaction, support B2.
See, don't get confused. We are talking about, at A you are getting 2 unknown displacements plus 2 unknown displacement. So you guys are saying 4.
Sir.
Anybody want to
2,
exchange
sir.
your answers? Anybody
2,
else?
sir. 2, sir. 2, sir.
What are those 2?
Sir, only that horizontal reaction only, sir.
Yeah.
So it is displacement technique.
Displacement at?
Sir, due to horizontal force only, sir.
Yeah, due to horizontal force. Displacement at what points?
At
Displacement at
A1 and B1.
Okay. And now finally you guys are left with option 1. Anybody want to take this option 1? Now see, the first thing is, imagine this we have already discussed. As horizontal force is applied here, which type of force it is to the member AB? Is it a axial force or it will be a transverse force?
Axial force. Sir.
Axial force. That means because of the axial force, which type of effects will act on the beam?
Horizontal force only.
Only horizontal will exist. So
Yeah.
there is no point of vertical displacement and there is no
Movement.
point of rotation.
Yes, sir.
So only there is a possibility of getting horizontal displacements, isn't it? Now tell me, whatever the rigid, is it a rigid body motion or not?
Rigid body motion, sir.
If it is a rigid body motion, let us
Yes.
say from the initial point, let us say it is displaced by an amount delta. And can you tell me what is this amount? What is this deflection? Because of the applied force, if it has moved to the point delta, how much B should have moved? What is meant by rigid body motion? Initially, it is there at one point and it is moved to some other point. That's it, right? Here also it will be delta. If this delta is known, don't I know this delta?
Yes, sir.
Both are
Yes, sir.
same.
Yes, sir.
Now, how many unknown? That's why I'm telling you, how many independent displacements? In this case, even though A has moved by an amount delta, B is also have moved an amount delta. But still,
1.
tell me what is the indeterminacy? 1.
1, sir.
Why?
1.
Because we will always speak about the independent degrees of freedom. So whenever you guys are thinking about kinematic indeterminacy, you guys have to think in your mind that you have to take the independent.
Sorry, sir.
Now, is it fine?
Clear,
It's
sir.
clear, right? Now,
Clear,
let
sir.
me give you, let us solve one more problem. First of all, tell me, see, one more thing in the exam, people or students usually get confused is if they ask this static indeterminacy, we might submit kinematic indeterminacy. So let us, while solving the problem, let us clear our minds. If it is kinematic, we have to think about the rotation or unknown displacements. If you are talking about the static indeterminacy, we have to think about the forces. Now, let us say this is A, B, and C. Now tell me, what is the static indeterminacy?
Two, sir.
Static indeterminacy.
Sir, 1, sir.
One, sir.
How come you guys are saying 2? How many reactions will exist at point A? 2.
Sir.
2.
Unknown forces. Here I am writing unknown forces. At point B, how many will exist?
One, sir.
1. At point C, how many will exist?
One, sir.
1. So total how many forces?
Four.
4 unknown
Plus
forces,
3.
3
minus
equilibrium equations. So total static indeterminacy is 1. Now coming about decay, kinematic indeterminacy. Now tell me, at A, how many will exist?
1.
Kinematic indeterminacy. Now we have to think about
Right.
displacements.
Yes, sir. 1, sir.
Five.
At A, 1, sir.
At A1, what is it? Rotation.
Theta.
And at B,
Theta.
let's say theta A. And at B, how many are possible?
2, sir. At B, 2, sir.
At B2,
Theta.
At B, 2, sir. 2, sir.
what are they?
Rotation and
Rotation and
Rotation at B
horizontal
displacement.
force,
and
sir.
also horizontal displacement at B.
And also see the 2, sir.
At C2, what are they? Rotation at
Rotation
point
and
C
horizontal.
horizontal.
and horizontal displacement at C.
Yes, sir. Yes, sir.
Now total, what is the kinematic indeterminacy?
5, sir.
1, 2, 3, 4, 5.
5.
9, 5, sorry, 5. Now, if I can tell you that beams are axially rigid, what does it mean? What is mean by axially rigid?
No displacement on horizontal.
Let us, before coming to discussing this, let me give you one more example. The same example I will consider. Now you guys tell me, how many unknown forces will exist at point A?
2, sir.
Is it 2? Everybody will agree to it?
2, sir. Sir,
What
DK
is-
or BS, sir.
What is the difference? See the difference between this case and this case. What is the difference? I have given it to you guys.
Vertical loading is
That means, what is the
A
difference?
will be 1, sir.
This
One-
we
one,
have
sir.
to, general case, this case you have to idealize, but
Vertical
this you have to think with respect to the given loading. So how many reactions will exist here?
Yes, sir.
1, sir. At A.
A 1, sir.
Vertical reaction.
A 1.
And here?
Mm,
And
B 1,
here?
sir. C 1, sir.
Total how many reactions?
3, sir. 3 minus
3.
3.
How many equilibrium equations?
3.
2.
So this is where we should
2.
not, 2. What
sir.
are they?
2.
We are
sir.
not considering the horizontal, so I will consider only summation along y0 and summation of moment 0. 3 minus 2, how many? 1.
1.
Is there any change in the indeterminacy, static indeterminacy here? No, right? Here also 1, and the previous case is also
No,
1.
sir.
Now tell me, how
Same,
many unknown displacements will exist at point A? How
One,
many
sir.
unknown displacements?
Theta.
1, what is it? rotation at A.
One the sir. One the sir.
And at
Yes,
B,
sir.
how many unknown displacements are possible?
1, sir.
1 or 2?
1, sir.
Why?
1,
Because
sir.
as horizontal
One,
loads are not applied,
One sir. One sir.
1. As horizontal
Yes, sir.
forces are not there,
Moment
there is no point of horizontal
Moment
displacement.
only sir.
So only rotations are possible.
Moment only sir.
Rotations are different, movements are different. So, well, we can just think about in our mind. Similarly, at point C, how many unknown displacements are possible?
1, sir.
1, sir.
What is it? Rotation at point C. Now, what is the kinematic indeterminacy?
3
3,
sir.
sir.
3. Now, here, what is the kinematic indeterminacy? 5.
5 sir.
Here, what is the kinematic indeterminacy? 3.
3
Now,
sir.
calmly look about where the difference has come here. See these
At
three
vertical loads.
and then see these three. Sorry, see these three. What are the degrees of freedom or what are the displacements that you have ignored from here?
Axial, sir.
What are the displacement that you have guys have ignored?
Axial force.
Axial, right?
Actual
Theta
display.
B and theta C. So what happens in generally, whatever the structures that are existing in reality, if it is a frame type of structure, then the axial rigidity. How to define the axial rigidity? What is the flexural rigidity?
EI, sir.
EI. What is the axial rigidity?
AI, sir.
AE, sir.
AE.
AE.
Right. Suppose if I want to find out the deflection due to flexure, then what is the formula then? You might have some integral m over dx divided by EI. If your EI is so large, then what happens to your deflection? It will
Decrease.
be 0. If it
Decrease,
is
sir.
infinity, then it is 0, right? Rigidity means that these values are so high such that you don't have any deflection. That will be very, very, very minute and you can be neglected. That means if these are axially rigid member, that means there won't be any axial deflection in the member AB. There won't be any axial deflection in the member BC. That means out of these 5, if these are axially rigid, how many I can neglect it? 2.
2.
That's why here it is 5 minus 2, that is 3. Are you getting the same answer or not? Here also.
Yes, sir.
If the specific loading is given, according to that we can find out. If not, if they are axially rigid, then also you can say, isn't it? So this is what the difference that we can make it. As of now, any doubt?
No, sir.
No, right? Now, what I want you guys tell me. What is the, I think you guys can quickly tell me what is the static indeterminacy without solving anything.
2 sir.
Unknown.
2 sir. 2.
2, right? Now, you guys don't be in a hurry. If you guys else the quickly answer the answer, then you guys won't get any points. So just try to tell me, think about it and tell me what is the kinematic indeterminacy and also what is the kinematic indeterminacy if the members are axially rigid. Okay, just take 2 minutes of time and then solve it.
Kinematic indeterminacy 1 sir. Only at the point A we have only rotation.
7, sir.
Because
It's
actually
not.
rigid.
It's actually rigid.
Sir,
Yeah, guys, sorry. Yeah, tell me what is the indeterminacy?
1 sir. 1
1.
7.
rotation at A, theta A. Kinematic indeterminacy sir.
Theta A. And any other answers? Everybody will agree with it. Point 1.
Yes, sir. 1 only, sir. Because
Now tell me. Now tell me. Here, why I am considering theta b? Why you have considered theta b? Just because you are having the support here?
Polar support to rotation.
Here what I am asking is that you have considered only theta a, isn't it? You
Yes, sir.
guys have not considered a displacement at point B, at point C. Now my question is, why you guys have ignored the unknown displacements at B and at C? Here, why you guys have considered B and C also? What is the difference?
It will be beam on the, it is beam, sir. It will be frame, sir.
In a frames? So here, see, wherever there is a transition, that means wherever there is a
Both
change
A
in
and
the
B same.
sorry, ma, I think your voice is not clearly audible. So at point A, we have to consider. Similarly, at B, the transition is happening in the member, or member orientation is changing. So wherever there is a change in the orientation, we have to consider the displacements at that point also. So at this point B also you have to consider unknown displacements. At this point C also you have to consider, and at point D also you have to consider. At point D, as it is a fixed support, every value is 0. Now at point B, how many unknown displacements might exist?
One, sir.
Theta P and theta C, yes, sir.
One.
Now I am considering a point in a 2D frame. Again, I am telling you, if you are considering a point in a 2D structure,
Sir, two possible, sir. Theta B, theta BC. Two cases are possible.
here I am not talking about, I am not given any loading, right? There might be horizontal loads present, there might be vertical loads also present there. If it is a 2D point, if you are considering a point in 2D, rotation at B possible,
Theta
deflection
C.
along horizontal possible, deflection along vertical possible. At point C similarly, deflection along X is possible, deflection along Y is possible, and also there will be rotation. So total how many? At point B, 3,
2,
at point C, 3,
4.
1 plus 3 plus 3. How many?
3 plus.
Is it clear?
7.
What are those 7? Any doubt?
Yes, sir.
Sir,
Yes, sir. Yes, sir.
BA and the DC is equal length, sir. Are you
B,
assuming like that? BA and CD is equal length?
there might be in different length also, no matter. Even
Okay.
the D extends to here. How does it matter? Here I'll take 1 point and here I'll take 1 point. In between I can find out by using displacement function. Doesn't matter. Okay, guys, any doubt in what are those 7? Is it clear?
Clear, sir.
You guys are sure, right? What are those 7? Once again, I'm asking, as I'm not, why I'm asking so many times is that whatever you guys are speaking, it's not clearly audible for me. That's why I don't know whether I'm completely satisfying your questions or not. So that's fine. If you guys don't have any doubt, now tell me, if they are axially rigid, what are those values?
Sir, at the point A, we have only one theta A.
5.
Then at the point theta B, then theta C. And if it is actually rigid, means if we have lateral load, theta del X will be there, no, sir. Am I right?
Sir, 4, sir. Answer. 4, sir.
4. How? What are those 4?
Point A, 1 theta A.
See, as of now, I think by simply, I think you guys might have already studied essay, so it will be very easy to give the answer for this. But the point is, what are the value you are saying? If you can visualize those values in the diagram, then that is what you guys are needed. Those who are saying 4, can you guys please tell me what are those 4?
So theta A,
Yeah, right.
theta B, theta C,
Right. Theta B.
Theta C with 2, sir. 2, sir.
then
And
del
deflection.
X, sir. Then del X.
Theta.
Then del X of what?
Del X
To deform displacement.
displacement.
Displacement,
Okay.
sir.
Now tell me why I should not consider delta Y.
So delta Y at the point B, BA, it would be the axial deformation, but
Yeah.
the member is axially rigid.
Hmm.
There won't be development delta Y.
Any other options that you guys want to discuss about this? Everybody agrees with 4, or you guys want to change your answer?
Two, sir.
What are those 2?
Sir, theta A, theta B, theta C, same only.
Hey, how come they are same?
Same
No,
rotation.
no. They won't be. They won't be. They will be different, obviously. And those who gave correct answer for this, what I am expecting from them is to, I think I'm making it so much complicated, right? Instead, I can do further simplify. Guys, don't think that we are taking too much time. It's just we are understanding the problems, okay? Now, what is the kinematic indeterminacy? I will come to the previous problem after completion of this. Okay, so don't worry, those guys didn't understand, that's fine. Now tell me, what about here DK? Tell me in general, first of all, I'm not talking about axially rigid.
5, sir. General.
Forget about axially rigid, now tell me the answer. At point C,
So
what is
5,
the independent degrees of
5.
freedom?
5.
5, sir.
At C, 0. At B, how many?
3, sir.
Rotation,
3, sir.
horizontal, vertical. And at point A, how many?
2, sir.
2,
What are
sir.
it? Vertical and rotation.
Rotation.
5. Now tell me, if they are axially rigid,
Okay.
what is the kinematic indeterminacy?
3, sir.
3.
Sir.
Everybody will agree? What are those 3? Can you guys please explain me?
B.
Come on, guys. Rotations, you can directly tell me. What are they? I can say theta A and
Theta A,
yeah.
theta
And what
B,
about another one?
and deflect
Along
along with
AB, we have a displacement, sir.
Which
displacement.
displacement you are talking about?
At the point A, we have a
Let me give you
displacement.
the direction x and y.
Y direction, we have a displacement.
Why we are considering only at y? Why can't I consider delta y at b or delta x at b?
Since the member is actually loaded at the point,
Yeah,
that is why EC and BA, we don't have any axial displacements.
we don't have any axial displacement. Okay, that means I can say dx, but what about delta y?
Delta Y is the displacement along the member BA, so we are not considering an answer.
Yeah, whenever you are speaking delta y, yeah, here it will be delta y, then here it is also delta y. Now, let me explain this problem first of all, and then it will be clear. Members are axially rigid means member might move to another place, just like this example. Just like this exam, where is it? Sorry guys, sorry. Yeah, just like in this example, as they are axially rigid, then what happens? It might move to one place. If it has moved to one place, then at both ends, the unknown displacement can be defined it by using only one value. With the same logic, let me explain this problem. Here it is. Obviously, rotation will exist here, rotation will exist here, rotation will exist here. Okay. Now let me start with point A. What we have discussed? We have discussed that members are axially rigid. Now tell me, is there what is the vertical displacement at point A? What is the axial force direction for the member AB?
0, sir.
The axial force direction for the member AB is vertical direction. So A, what is the vertical deflection at point A? 0. Now we are saying that member is axially rigid. That means if this point moves, then point B will also move by the same amount. But what happens at point A, as there is a support, that will not allow any vertical deflection. In the vertical means vertical represents the axial direction here. That's why as the vertical deflection is, just wait on a second, guys. Just 2 minutes. Yeah, sorry. So there is no vertical displacement at point A, and similarly there is no vertical displacement at point B. So here previously what we have considered, horizontal we have considered, vertical we have considered, rotation we have considered. As this vertical is equal to 0, as this is axially rigid, vertical deflection at point B is also not possible. So that's why out of these three, what I can eliminate? I can eliminate this vertical direction. Now, similarly, what is the vertical displacement at point D? Similarly, this point D also won't allow any vertical deflection because it is a fixed support. So as the vertical displacement at this point is 0, what is the vertical displacement at point C?
No, sir.
This one initially we have considered again horizontal, vertical and rotation. But as this support will not allow any vertical deflection because of the axial rigidity, vertical deflection at point C is also equal to 0. That's why what I will eliminate? I will eliminate this vertical too. Now how many we have left with? Total 1, 2, 3, 4, 5. Now again, what is the axial direction for member AC? Horizontal.
Horizontal.
Right.
Horizontal.
Is there any support at point B that
No.
will not allow any horizontal displacements? No. Just like if you see at point A, as it is a support, it will not allow any vertical deflection. But at point B, is there any such support like that?
No, sir.
No. Right? So that's why
Okay.
deflection, horizontal deflection might possible at point B. Similarly, is there any support reaction existing at point C that will not allow any deflection? No, right? That means deflection at B is also possible. Horizontal deflection at C is also possible. But what we are saying, these members are axially rigid. What does it mean? If this point is moved by an amount delta, point C also will move by an amount delta. That means rotation at A I will consider, rotation at B I will consider, rotation at C I will consider. In addition to 3, out of these 2, then what I will consider? I will consider 1 plus 1. That is either horizontal deflection at B or horizontal deflection at C. That's why total how many? 4. Is it clear? Any doubt?
Yes, sir.
What if I draw the deflected shape here? The deflected shape might like this. So from here to here, what is the amount? Delta. From here to here, what is the amount? Delta. What happens if I keep a support like this? Now can you tell me what is the answer?
Mm.
If I have created an additional support at point B, Can you guys tell me what is the answer?
Then
What
we
is the
don't have
kinematic
value
indeterminacy?
displacement. 3 only, sir. All are
Three,
rotation
sir.
only.
Only all are rotations.
Initially for minus, it will not allow any horizontal displacement. If it is not moving, this one will also not move. So out of those four, again, I will neglect one. So total how many? Rotation at A, rotation at B, and rotation at C. If I see the reflected shape, how it will be? It will be like this. Clear? Is it clear about kinematic indeterminacy?
Yes, sir. Clear, sir.
Now,
Clear, sir.
now tell me here. With the same example, what I can consider? What is the axial direction for member BC?
Horizontal, sir.
Horizontal. This will it allow any horizontal deflection?
No.
That's why
No, sir.
horizontal
No, sir.
deflection is not possible. Horizontal deflection at B is also not possible. What is the vertical direction? Axial direction for member AB? Vertical.
Correct, sir.
Point A allows the vertical deflection or not?
Yes,
It
sir.
will allow. That means point B will also move by the same amount. So that's why what are the unknowns? Theta A, theta B. In addition to it, delta Y. So there is a formula like, if you want to consider axially rigid members, what you can do is that total degree indeterminacy minus number of members. So initially we have counted as 5. How many members are existing? 2.
2 numbers.
So 5 minus 2, 3.
3 only.
My point is that instead of blindly following this, you should also have to
Sir,
understand
sorry.
what are those.
Sir,
Yeah,
sorry.
please.
Sir, del Y I am not getting. Could you please explain once again?
Yeah. Now, what is the axial force direction for member AB? Y direction according to it, right?
Yes, sir.
Now, what is the type of support at B? Like, what is the type of joint? It is a rigid joint. Usually, we will consider, right?
Yes, rigid joints.
Before that, what is mean by rigid joint?
Rigid joint means
I should have guys tell you. Rigid joint means that all the members will rotate at the same rotation. That means here how many members are connected? 2. If it is a rigid joint, this rotation, if it is theta, this rotation is also theta. If it is a rigid joint, all the members are rotated by the same amount. Now you can tell me, as it is a rigid joint, rotation is also possible. At
Yes,
this
sir.
joint, horizontal deflection is possible. Vertical deflection is also possible, right?
Yes, sir.
Now we have seen that this is 0 because of the fixed support. Here, what is the axial force direction? 0. As it is
Yes.
axially rigid, this one also will not have any horizontal, so this is 0. Now at point B, vertical deflection is possible,
Yes, sir.
right? Similarly, at point A,
This del X is axial deformation or what, sir?
yeah, I see for the member AB, what is the axial deformation direction?
AB is along Y direction, sir.
Along Y direction. For member BC,
BC
Yes.
along X direction.
that's why if you are looking for member BC, for axial deformations, we have talked about along X direction displacements.
So del X is axial deformation. Okay.
Yeah, now for you it's clear, right?
Yes, sir.
Okay then. Now with this, now before going to find out something, I will write type of joint, unknown displacements I want to see. Let me write it down nicely so that it might be helpful. Is the size of the letters are okay? Sorry guys, today there is a power cut at my place around 8:30, so For today class, we might have to end up at 8:30. Hope you guys are fine with it. Okay. Now,
Okay.
let me start with rigid joint. What does the symbol means? Continuous, right? Forget about them. If it is a rigid joint, additional equations that you will come to know after. There are no additional equations for rigid support. How many unknown displacements are possible if it is a rigid joint?
No possible for
No possible. Zero.
Unknown displacement, rigid joint. It
Zero.
is not a support.
3, sir.
3. If
Three,
it is
sir.
a case, 3. What are they? Delta x,
Delta
delta
y.
y, and theta.
Theta.
Rotation.
Rotation.
If I am talking about 3D, how many unknown displacements will exist? Here I am
6, sir.
getting into the 3D also. What are they? Delta x, delta y, delta x,
Delta is
theta y,
Theta y.
theta z.
Theta is it.
Now, what if there is a hinge joint or pin connection, hinge joint? What is the property of the hinge?
There is no moment.
Moments are 0, right? How many additional equations are possible if it is a hinge joint?
Two
Here, how many
Two,
members
sir.
are connected?
2 members.
Two members.
Two members
members,
are
sir.
connected, then how many additional equations are possible?
1.
One, sir, one.
That is, moment at that point is equal to 0. Now tell me, how many unknown displacements are possible? What is the difference between these two? Can you tell me what is the best example for hinge joint in our body parts?
Elbow.
Anything, any part you take it. They can freely rotate, isn't it? Now, how many unknown displacements are possible? Even if you take the elbow joint, they can rotate by different amount. What you can see, will they move by the different value of displacement? Like one have moved in downward and another have moved down upward.
Two possible.
So if it is a hinge, first thing is that it is not resisting any movement, isn't it? If it is not resisting any movement, then because of the rotation movement, which are rotations are possible. As resisting movements are not there, then rotations of the members might be different. That means for this, the member rotation, if it is like this, theta 1, and for the member 2, rotation may be different, that is theta 2. But what about if it is a rigid joint? They will be rotated by the same amount, theta 1 and theta 1. So, displacement along x direction is possible. Displacement along y direction is possible. In addition to it, what happens? Rotation at 1 and rotation at 2. So total how many here?
4.
Now did you find the difference here and here? Now, similarly, if there is a hinge joint like this, how many additional equations are possible? Again, I am talking about this is in 2D. How many members are connected? 3.
3 members.
3 minus 1, 2. We have already seen y2. And now tell me, how many unknown displacements are possible? Delta x is possible. Delta y is possible.
Delta y.
How many rotations are possible there? How many members are connected?
3, sir.
3.
3
Three, sir,
members.
three.
As it is a hinge, 3 different
possible,
rotations are possible. So that's why.
5.
So total 5.
5.
Here I have considered 3. There might be 4, there might be 5, there might be 6. It doesn't matter. You know the logic, isn't it? Is it clear?
Clear, sir.
Now, if I have considered the same hinge, but I have considered in 3D direction. That means there is a hinge in 3D frame. Can you tell me how many additional equations are possible? Now this is where you have to apply the logic.
Del X, del Y.
What is the question? How
2,
many?
sir.
What is my question? How many additional equations are possible? See,
2, sir.
if it is 2D, how many additional equations? 1. Can you tell me what is this equation?
1, sir.
What is the
MC
equation? Moment,
equals
if this is point C, MC is equal to 0.
0.
Now, what happens if it is in 3D?
Two,
What is the
sir.
change that you will observe? 2.
Two,
If it is 2,
two,
what
two,
are
sir.
they?
3.
Moment, rotation.
If it is a hinge, resisting movement will not be there. Resisting movement is 0. What is the difference between 2D and 3D? In a 2D, how many movements are possible? 1.
One
If
moment.
it is a 3D, how many movements directions are possible?
3 moment.
Three.
That means what you can say, movement at this point along x direction is 0, along y direction is equal to 0, along
0.
z equal to 0. Total how many are possible?
3.
What are those? Movement along x equal to 0, movement along y equal to 0, movement along z is equal to 0. Now with the same logic, can you guys tell me how many unknown displacements will be there? Now, first of all, come to the displacements. It is a 3D. So how many displacements are possible?
3.
What-
3,
what
sir.
are
Del X.
Delta
Del X,
Delta Y,
del Y, del Z.
delta Z. Now, think of about x direction. Along x direction, how many rotations are possible?
3, sir.
Along the x direction, I'm talking about theta x.
2, sir.
For this member, theta x will be different. For this member, theta x will be different. So, theta x for member 1, theta x for member 2. Similarly, for member y, along y direction, sorry.
Theta
Rotation for
Y1,
member
theta
1.
Y2.
Similarly, along z direction, theta z1, theta z2. So, total how many?
6.
3 plus
9, sir.
9, sir.
9. Is it clear? Now tell me, in this case, if it is 3D, how many additional equations are possible? If it is 2D, we are taking 1. If it is 3D, multiplied by number of directions. How many number of directions? 3. Just apply the
3.
same logic.
3 into 2, 6, sir.
3 into 2. You have to visualize those 6. Then only you can solve each and every problem. Now similarly, how many unknown displacements? Delta x, delta y, delta z common? Any doubt?
No, sir.
Now, think about x direction. Along x direction, how many rotations are possible?
3.
Like that, how many directions are there?
3 directions.
So, if you take along x direction, 3 different rotations
Totally
are
12,
possible along
sir.
x. If you take y, along y also 3 different rotations. If you take z, along z also 3 different rotations. So, total 3 times 3 rotations. 3 per directions, x, y, z. That will be equal to 9. So, total how many? Any doubt as of now? Or is it very much clear?
Clear, sir.
Yeah, this is okay, sir.
Everybody. I'm need from everybody.
Clear, sir.
Clear, sir.
Sir,
Yeah,
one doubt.
yeah.
Can you explain about the degree of indeterminacy, internal and external one?
Explain about what?
Internal degree of indeterminacy, external degree of indeterminacy.
You want what is internal indeterminacy and what is external indeterminacy?
Yes, sir. Yes, sir.
So internal is just be possible because of the arrangement of the members. And external indeterminacy is possible because of the support reactions. Now, if I take a simple frame like this, if I talk about external indeterminacy, first I will look at the supports. Here, 3 unknown reactions are possible. Here, 3 unknown reactions are possible. So total, if I take free body diagram of entire structure, 6 unknowns, 3 equilibrium equations. So 3 unknowns are there, isn't it?
Okay.
Now the point is, now let us assume that you know the support reactions. If you
Yes, sir.
know the support reactions, can you find out all the internal forces in the members or not? This
Yes,
point,
sir.
we will not discuss it for beams generally. Why? Because the beams are oriented along one direction. So if you resolve or if you separate beam at a point, those reactions will be opposite to each other. That's why for beams, generally we won't talk about internal indeterminacy. But if you see, look at this joint. If you look at the joint A, and if I separate at that point, in one case, let us assume that 3 members are connected. In another case, let us assume that only 2 members are connected. And again, I am separating them. At this point, how many internal forces are possible? 3. At
Yes, sir.
this point, how many internal forces are possible? 3.
3.
At this point, how many are possible? 3.
3.
Similarly, if 2 members are connected, at this point, how many are possible? 3.
3.
At this point, how many are possible? 3.
3.
Now tell me, if I know these 3, can I know this or not?
Yes, sir.
Yes, sir.
Why? If this is in a horizontal direction, then this I will take it as a left. If it is upward, this I can take it as a downward. If it is clockwise, there I will take it as a anti-clockwise. Isn't it?
Yes, yes, sir.
Similarly, let us assume that at this joint, I know these forces. Horizontal force is 10, downward is 20, and rotation is 40. Now the point is, if I know these 3, can I find either this one or this one? Can I or cannot? Can
Yes,
I
sir. We
apply the
can.
same logic here?
Yes, sir. We can, sir.
We cannot here. Why? Because here we are just taking simply opposite reactions. But here also 3 will be possible. Here also 3 will be possible. What is the condition we talk about? At that joint, if we talk about, we'll say summation of x 0, we'll say summation fy 0, and say
Moment 0.
0. Now, because of these 3, if I take here, if I'm considering on the right side, if I add forces along this direction, they should be 0. How can I make them is equal to 0? If I'm acting 10 as right side, if I consider at this point left side 10, then only if you sum it up, then you will get 0. But here what happens? Instead of single point, we may get horizontal force here, and we may have horizontal force here. Let us say this is delta x1, this is delta x2. If I apply that condition, delta fx, what I will get? At this joint, what is the x direction force? 10. At this node, what is the x direction force? Delta x1. In this, what is the x direction? Delta x2. If I add those two, how much I'll get? 0.
Equal 0.
If I know this one, can I find out this one or not?
Yes, sir.
Right? Why? Because if I add these two, this should be equal to 0. Similarly, if I write it down along y direction, what I will get? 20 plus force along y1 plus force along y2, that will be 0. If I
0.
know this one, can I find out this or not?
Yes, sir.
Similarly, if I write down for moment, again, if I know one, I can find one. That means from this equation, I need one unknown. From this equation, I need one unknown. And from this, I need one unknown. That means you can say that out of this, either these three or these three, if I know any one of these three, then I can find out the another three by using summations.
Okay, sir, but how we are finding the first one, sir? FX1.
Yeah, that's what the question, that if we solve the problem, that we will come to know. But if I can tell it to you, how can, again, it will be a big problem. It will take so much time. So we'll discuss all those things later in problems. But as of now, you guys just have to get the idea how it will be.
Okay.
I think I have tried all possible way by explain with some example problem. But these type of problems we cannot, isn't it? We cannot able to. We cannot solve this big problem, and I can show it to you how they can be known. But it's clear, right?
Yes, sir.
Internal
Clear,
reactions.
sir. Clear, sir.
Yeah. Okay.
Yeah, okay, then I think we should wind up here. Okay. At any time, power might on.
Sir,
Okay. Yeah, please.
sir, in the last problem, you have mentioned some del X. Could you go to the previous slide, sir?
No, this is not delta X, this is force, okay?
No, not this one, sir. 3 to 4 slides. The L-shaped member. This is the one. L-shaped member. Here you have written del Y right now, sir.
Yeah.
This actually it will not come. It will not come.
Maybe along maybe we don't have any displacements, right? Del Y equal to 0. Then how it is coming del Y?
Where del Y is equal to 0 in this case?
In this case,
Partially.
along A, at the point A, we don't have any displacements, right?
It is a roller support. It is placed along which direction? Roller support. Roller is oriented along y direction. So y direction possible, right?
Yes, sir. Yes, sir. Yes, sir.
Yeah. If it is fixed, according to you, if it is spin,
Yes.
this is also equal to 0, then you will get only 2.
You are right.
Yeah. Fine.
Yes, sir.
Okay, then thank you guys. Thank you for having me today. Bye.
Thank you, sir.
Thank you, sir.
Thank you.
Thank
Thank
you,
you,
sir.
sir.